Okay, in this video we want to discuss the notion of conflict serializability and talk about a couple of examples of how you might determine whether a particular schedule is conflict serializable or not. And remember, the technique for doing this is to build a precedence graph, and I've kind of set up two partial precedence graphs down here, and I'll fill them in with the particular schedules in a moment. So in any case, here's our two transactions, T1 and T2. They both do the same thing as far as shared data is concerned, but the sequence of operations can potentially be interleaved, as we see, for example, in Schedule 1. Okay, so we can see in Schedule 1 that T1 reads and writes X, then T2 reads X, T1 reads Y, T2 writes X, and so on and so on. Alright, so the deal with conflict serializability is to look to conflicts. And basically, it's wherever you've got a write operation on a shared data item. So straight up, we have an example here of a conflict. We've got a write of X and then a read of X. So there's a precedence in the order that those two operations happen. So the write comes before the read, and we indicate that on the graph by putting an arc between the two relevant transactions. So let's do that. So I'll make a copy of that arc, and then I'll connect it up to the transaction. So what this basically says is that transaction 1 performs an operation on X before transaction 2 does, and it's a conflicting operation. In other words, there's a write. Okay, there's no conflict here because it's a different data item. No conflict here because there's a different data item. You could argue there's a conflict here and here, but we've already captured that by that arc there. No conflict here, but there is a conflict here. So in this case, transaction 1 writes Y before transaction 2 reads it, and therefore there's an arc between T1 and T2, and the precedence is going from, once again, T1 to T2. So let's put that arc in position. And okay, there's a conflict there, but that's already captured by that arc there. Okay, so remember, if you remember, the idea with conflict serializability is that we look for cycles in the precedence graph. Now this is the complete precedence graph for this schedule up here, and there are no cycles. So this schedule is conflict serializable against the two transactions. Okay, let's take a look at Schedule 2. Okay, so it's a different interleaving of the operations. Right, so let's start looking through for the precedence. Okay, so we've got a read and a write here. T1 takes precedence over T2 as far as modifying X goes. So we need to make a copy of this arc onto the precedence graph, and that's going to give us this connection. So T1 precedes T2 as far as manipulating X goes. The next thing we can look at is these two operations here, and we can see that there's a conflict there and there's also a precedence. So T2 manipulates X before T1 does. So we need to put an arc from T2 to T1 based on X, and that will give us this graph here. And straight away we can see that there's a cycle in this graph. So this schedule here can't possibly be equivalent to any sequential execution of T1 and T2. So neither T1 then T2 nor T2 then T1. If I wanted to finish off the graph, I could also talk about the precedence here with the shared variable y, and that would simply result on extra arcs in the graph. So let's, for the sake of completeness, add that arc in, and so this would give us an arc there. Bit of a strange looking arc, but nevertheless you get the point. And there's precedence from T2 to T1, so I could put this arc up here and connect. T2 manipulates T1 before y, so there are in fact two cycles in the graph. So there's a cycle based on x and a cycle based on y. So schedule 2 cannot possibly be equivalent to any serial schedule of those two transactions. So conflict serializability, build a precedence graph, look for cycles.